Good morning, good afternoon, good evening. This is Mr. Payne bringing you Measures of Central Tendency, Unit 10, Lesson 3. The objective for today, you will be able to find the mean and the median of data both by hand and with a calculator. You will also be able to understand the difference between a fair sample and an unfair sample. In our day-to-day activities, we deal with many problems that involve related items of numerical information called data. Statistics is the study of sets of such numerical data. When we gather numerical data, besides displaying it, we often want to know a single number that is representative of the data as a whole. We call these types of numbers measures of central tendency. The two most common measures of central tendency are mean and median. Let's just refresh our memory real quick and understand what mean is. Don't forget that the word mean means average. How do we find the average? We add up all our numbers, and then we divide by the number of samples that we have. Median is the middle number after we put it in order numerically, either ascending or descending. So let's read exercise number 1. A survey was taken amongst 12 people on the number of passwords they currently have to remember. The results in ascending order are shown below. State the median number of passwords and the mean number of passwords. So the first thing I'm going to find is the mean. I'm going to add up all these numbers. When I add them all up, I get an answer of 29. They said that there are 12 total people, so I'm going to divide 29 by 12. And that's going to give me a mean of 2.4. Once again, the first thing you're going to do, add up all your numbers. Once you add them all up, you get an answer of 29. Then you divide by the number of people you have, which is 12, or the number of pieces of data you have, which is 12, and you get 2.4. The next one we're going to talk about is the median. Because it's in ascending order means that it's going from low to high. All I have to do is cross them off as I go and find the middle number. Oh, I have a little bit of a problem there. You see how 2 and 3 are left in the middle? If I were to cross both of those out, there would be nothing left. So I have to find what is in between 2 and 3. Well, this one's easy because what is between 2 and 3? That's 2.5. But if you're not sure how we got that, you do 2 plus 3, which gives me 5. Then you divide that by 2. 5 divided by 2 is 2.5. Exercise number 2. Students in Mr. Okafor's algebra class were trying to determine if people speed along a certain section of roadway. They collected speeds of 20 vehicles as displayed in the table below. I'm going to underline something right away, 20 vehicles, because that's going to help me find my mean. Find the mean and the median for the data set below. Well, how many cars were at 29? One car was at 29. And what you're going to have to do is write out each one of these numbers in order to get an accurate reading. How many cars were at 33? 2 were, so I write 33 plus 33 plus 34 plus 34 plus 34 plus 34. Because there were 4 cars at 34. 35, 35. And you should be doing this along with me. This is a great strategy for making sure that we get all these questions right. So you should have 20 pieces of data. One of the things when you type this into your calculator that you want to make sure that you do is recount. Make sure that I have 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Make sure you have 20 in your calculator. Now go ahead and hit enter. And then hit divide by 21, or divide by 20, divide by 20. And you're going to go ahead and get your answer for your mean. Your mean should have been 36.1. Now let's go ahead and do our median, crossing off on each side, and work our way all the way back towards the middle, like I did in problem number 1. So the middle number in between 35 and 35 is 35. So my median is 35. Let's answer question B. These are the types of questions that you're going to see on your Common Core Regents exam. The speed limit along this part of the highway is 35 miles per hour. Based on your results from Part A, is it fair to make a conclusion that the average driver does speed on this roadway? Well, I said no, and here's the reason why. If you add up the number of cars that are either at the speed limit or below, and you add that up, you get 5 plus 1 is 6, plus 4 is 10, plus 2 is 12. We have 12 cars out of 20 that are not speeding. I know that the average is 36.1, so you would maybe say that, yeah, on average, cars do speed. The problem with that is that we have one little outlier. We call it an outlier because he's a guy that is really well above the speed limit, and it skews our data a little bit and brings our mean or our average higher than what it really is. So you have to be careful of that. But it does show that more than half the cars do not speed on this roadway. Biased versus unbiased. Biased means unfair versus unbiased, which means fair. I know it's a little tricky because of the uns and getting them crisscrossed, but if I'm biased towards something, I'm going to be unfair. My decision is going to be unfair. If I'm unbiased, I'm level-headed, I'm not judgmental, I'll be a lot more fair. So let's read and have a couple of practice problems here. It says, when conducting a statistical study, it is not always possible to obtain information about every person or situation to which the study applies. Unlike a census, in which every person is counted, some studies use only a sample or portion of the items being investigated. Whenever a sample is taken, it is vital for it to be fair or unbiased. In other words, the sample reflects the overall population. To determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? Explain your choice and why the others are inappropriate. Well, let's go one by one. A baseball stadium. Who typically likes to go to a baseball stadium? Typically, it's people that like sports. So if I just like sports, I'm going to be more apt to watch sports on TV. So outside a baseball stadium is not going to give you a fair sample. A concert hall. If I like going to a concert hall, I'm going to be liking to listen to music or plays and stuff like that. So I'm going to be a certain type of people will be going to the concert hall. So it's going to give you an unfair sample. A grocery store. Well, everybody has to buy groceries, and all types of people go to the grocery store. So that is why it's going to give you the most fair sample. In a comedy club, the same thing goes with the baseball stadium and the concert hall. Only certain types of people will be going to a comedy club. Not all types of people like to go to a comedy club. So that's not going to give you a fair sample. That is a great explanation of what gives you a fair sample and what does not give you a fair sample. One of the key words in this exercise number 3 that is important for a fair sample is random. I am choosing all these people at random. However, where I choose them is also just as important. All right, for exercise number 4, Truong is trying to determine the average height of high school male students. Because he's on the basketball team, he uses the heights of 14 players on the team, which are given below in inches. I'm going to underline a couple key things in that sentence that are going to really help us throughout this exercise. He's trying to find the average height of high school male students. He uses the heights of his basketball team. Okay, it's easy, convenient. Instead of doing this by hand and typing these numbers into your calculator, I'm going to refresh your memory on how we use the list and use our stat button and what we're going to look for. So it says calculate the mean and median for the first data set. The first thing we need to do is remember, go to stat in our calculator, which is our list, and enter in our list, typing in each one of these numbers, hitting enter after the fact. Then hit stat again, arrow over to calc, hit our variable stats, and go down and take a look at our information. The bar that we're looking for first and foremost is the bar that says x equals, the very first bar. That's the one we're going to use today and right now. That means average. Okay? So it says here, calculate the mean and median for the data set. Round any non-integer answer to the nearest tenth. So 74.57, if I look at the 5, I underline the 5, I look to the 7 tells the 5 to go up. My mean is going to be 74.6. That's a 4, 74.6. The other couple things that I really want you to pay attention to, and I pointed this out, is whenever you type something in your calculator and you're using your stat button, make sure that you typed in the correct number of samples. So that's what this n equals 14. I have 14 numbers. Is that correct? I look up here, 14 players. That is correct. Then I scroll down, just like where I found the median for my box plots, and then I find my median. My median is right there in that piece of data. So my median is 74.5. And I'm sorry, the iPad is starting to act up a little bit as I'm recording, so my numbers and dots are really in a delay here. The last thing we have to talk about before the video is over is this data set above a fair sample? Let's think about this. For the average height of high school male students, explain your answer. Well, I'm going to let you come up with an answer on your own. I'm not going to give you one until we come back into class and we talk about this. So think about this. If I wanted to find the average height of all male high school students, should I use a sample set just from the basketball team? So tell me, is this fair or unfair, and why? Have a great night. Write up a good WSQ. Remember, recall our information is the best way to learn. Have a good night.